Hello, I'm Bill Wake. We're here working on an old basic program. We've converted the bulk of it to Swift, but we still have some work to do on the interaction. So it's, well, I can't say it's looking great, but it's looking kind of the way it used to back in 82 or whatever this thing's from. What we have still that's in the way is on the bottom line there, those arrows left, down, and right, and then the little hyper jump or jiggle arrow or button. All those right now are buttons, and what they do is they set simulated keyboard, sort of keyboard positions, I guess you'd say. And then the program that interprets it reads those keyboard positions and interprets it back into movement buttons or movement actions. The keyboard in these old machines is organized as a matrix, so there's a set of rows and a set of columns, and you do a poke command that turns on electricity to certain rows, and then you read from the columns to see which ones are hit, and given the bit combinations, you can judge which character it is. All right, not very Swift-like, not very iOS-like. All right, let's go to the IDE. Let me just save this. Okay, so I just ran tests, so we're okay there. Our main program here, what we've done so far is we've transliterated it from BASIC to Swift in a very primitive way. Then we did a bunch of refactorings. So some of those refactorings were standard, like rename and extract methods, but a bunch of more things like how do I combine two statements with a goto and an if so that they look like a structured if statement, things like that. So all the sort of structured programming conversions that if you ever knew about, you probably have forgotten, thankfully. All right, so what we're focused on is this keys to look for. These are setting bit flags that tell which row. So X, C, and comma are all in row 4 of the keyboard matrix on this old machine. And if you want the X, it's not 128, the C is not 64, and the comma is not 2. All right, let's give it a run. What we haven't done with this code is anything approaching, well, we haven't pulled out any objects, put it that way. It's all still pretty heavy on poking and figuring out coordinates and things like that. I don't think it's all terrible. I mean, no method is all that big. This main one's probably the biggest. But, it's not great. And the other thing that's on my mind, so the first thing is we don't have a way to detect when a button is pressed and when it's let go. So the way SwiftUI, the framework we're using, it's fairly new, and the way it works is if you press a button, you don't get any notification. You get a notification when you release the button. And we found some, we did a web search last time and found at least one promising approach, and we'll try that today. I'm just going to give this a run just so we see it once. And I don't think I've ever tried the jitter button, so let's see what we can do there. All right, so it draws the top, it draws the sides, then it fills in. Should really be 8 rows of blocks. I mean, the old thing, but it's 7. Okay, so I'm trying the jitter button and see if, yeah, we can kind of change the direction. That's handy. But jitter stays into effect until something else stops it, okay? Because this is kind of, the down arrow is the stop button, okay? But at any rate, we're chomping through, and let's see if we can. Notice hit, slide, go. Does the same thing on the walls because we give it 2 moves per turn, so it moves vertically and then it moves horizontally. All right. I'm trying to see if I can get a cluster of blocks knocked out. Oh, I should have used my little... All right, good enough. Can't spend all day on it. Although people probably did back in the day. Okay, so I think in our to-do, we left some information. Okay, make buttons work on touch down and up rather than needing a stop button. Okay, and the one we saw was this one. I don't think we've tried anything about it, but we'll give it a shot. So for testing of this thing, we've done a basically a pin down test. It takes a snapshot of the screen when the board is done doing whatever it did and does a hash code of that. And with that, we can sort of judge whether any other screen is equivalent to it. So it's not anything during the middle. It's all just kind of at the end. Okay, so why have two buttons? Yeah, the old framework, UI Kit, used to have touch up, touch down, drag, and so on. Okay, but SwiftUI, all you got is touch up inside. Okay, let's get down to some code. Okay, so press the button, toggles the state. Yeah, that's kind of annoying. All right, now this is the more complicated one. Okay. So what he does, oh, did I make up the name? Well, what they do. Let's see. So the core of it to me is this drag gesture. Okay, so they put a drag gesture in there with a minimum distance of 0. So I think that's what's detecting the touch down. This is called whenever the gesture is happening, because we do it on a drag, it's called when the finger is down. Okay, gesture state is 2. On gesture drag, on change, perform pressed, self change state pressed, self change state unpressed, and then you got a function that does that. Okay. Well, all right, let's... I don't know if I want to repeat the whole experiment that gets him there. I kind of just want the answer. Okay. Foreground color, background color, padding on touch down up event. I think that's his class up here. This is a modifier. Okay, let's take this, let's see what we can do. Okay, so in the content view, this is where our GUI stuff is now. We got a content view struct. I'm just going to add a new struct. Was it some view? Some view modifier? Oh, just a view modifier. Okay, does that give me an obligation? But, well, yes, I do. Body equals this is what I'm going to use for the body. Actually, the drag gesture too. Okay. So we created a drag gesture, and I think what we're going to do is, okay, we'll want to attach this drag gesture on. This is the modification we're making. All right, let's see. Call whenever the gesture is happening. Okay, so we need it is pressed. Gesture state, didn't I do that? Or is pressed, yeah, okay. All right, so we're updating is pressed. Value, gesture state transaction, true. Gesture state is true. Okay. And then our body, so that's all set up with the drag. I think I can squeeze that a little. We're going to return the body with some modifications. So drag, on drag, oh, gesture. All right, so we've attached the drag gesture to the content. And when it gets an on change, when is pressed changes. Now, I don't see what's turning it off. Maybe that's this. This is called when the finger is down. And I don't know about this change state. Okay, if is pressed is changed, call change state whenever the change occurs. Okay, yes. And then we're going to call change state with pressed or not pressed. And let's see, where's our, make sure we're closed to there, and then that's the parenthesis. Okay, so that's the gesture, that's the return, and then finally we got to put this method in. If you're on iPad, you put all this code in a separate file. Well, we're not on iPad. Change state. I don't know where that's coming from. Oh, we got to declare it. All right. So this is not something we need if we're not in the playground. I get it. Okay, and then we got to link, got to make this thing part of it. Okay, and I think I'm going to just let you change state. Okay, so I think you have to declare this. I'm just going to make it Boolean. Change state takes a Boolean and does something. Okay. I don't know, when pressed. Well, no, it's button pressed. Okay, so somebody's gonna have to initialize that. All right, so let's see if we true. Well, Okay, we'll refactor. False. I see the same thing based on the same state, so I can just do self.button pressed. It's true in this branch, false in this branch, so this is not needed. The risk is it's a little uglier. A little less comprehensible because it's got that Boolean instead of something that actually says I'm pressed or I'm not pressed. Self.button pressed. Okay, so I think what we're saying is when, well, I'm a little puzzled at the use of this. Updating is pressed. Value gesture stage. I don't know. That's a little funny to me. Like where's this being? Oh, that's this. Okay. Okay. I don't know if it must automatically set it false or something. Is that what this is doing? Okay. All right, and then the usage of this thing, I think we're just going to attach it on somebody's view. Updating is pressed. This is automatically set. Okay. Oh dear. Okay, so we add our modifier. And this is our to-do when we find out what state we're in. Okay. Let's see. So we got to find the button we put it on, and then add a modifier. Okay. Let's try it on this one. Okay. Here's the button. Dot modifier, and our modifier is our touch up thing. Touch up down. Modifier with a button pressed method. I think I can just, I don't need to say change state there. I can just pass it. I believe this, okay, and this is the Boolean, okay, is pressed. Well, how about button is pressed in, what are we going to do when the button's pressed? Okay. I think what we're trying to do is this stuff. Okay. If button is pressed, we're gonna do that, and then else it's not pressed, and we're gonna do this. Okay, and this will get us down. I don't know if we need this anymore. We can get it back if we need to. I don't even know if we need to put that on the. I don't know if that's a required argument. All right, so we're going to run, and our hope is when we press the left down button, it starts moving left, and when we let go, it stops. And that would be very nice. And then once we got that going, we'll get rid of this keyboard simulated stuff. That's just crazy. Okay, so we'll say go. Let it draw. First we'll move right because we don't have a choice. Okay, there's right. And now left. And nothing's happening. Oh, okay. All right. What have we forgotten? Okay, so I don't know, it's a little tricky to debug these things. I think I may just put some prints. Okay, so this print is drag pressed gesture state true. Okay. And we'll do a print here. Gesture changed. I don't know if this should be a $sign. Gesture changed pressed equals pressed. Okay. And let's put one more in up here. Button action. Okay, so I think we're going to get notified on all the interesting places. I don't know if maybe if I squeeze everything onto the screen at once, perhaps. All right, let's do go. I think this initial drawing should just get faster every time you do it, because I don't know. I don't know if there's any explicit slowdowns or if that sort of approximates the basic speed back from whenever. Okay, I'm going to hit stop. And now I'm going to hit left, hold it down, hold it down, hold it down, hold it down, and release. Okay, and let's see what we got. Where's my console? Is that on here? Nope. Where's the arrow for that? Output. Whoa. No output? All right, now I did have this question about this. Okay, Let's make sure this is even called body. And I don't know, I use this sometimes like a show a nesting and more bracket or angles going in if I'm deeper. Okay. And make sure, so this is pressed. That's gesture state, so it's only active while the gesture is doing its thing. Okay, go. All right. I'm puzzled why I'm entering that so many times. I mean, it's good that it's attached, but something's funny. Okay, here's left. Stop. Or that was right. Try and go left. Okay. And I'll stop. Okay, so lots of touchdown bodies entered. That's kind of odd. So that tells me this thing gets called touchdown modifier. All right, somehow. Okay, so we create this. We come in here, we call this. We create a drag gesture, we attach it. All right, I'm not seeing anything other than body. I don't know if this means we're reattaching it every time through the loop. That seems very odd. Very wasteful, but all right, let's first compare what we had to this person's. Okay, we have, I'm ignoring button state. We created a view modifier. We gave it a gesture state. Initial automatically resets when the gesture ends is canceled. Once the finger lifts up, it resets to false. That's handled inside the updating modifier. Let's see, it said something about iOS 14. Let's make sure we're running iOS 14. Oh, where will I find that? Hopefully on here. 14.5. Okay, so, and that's pretty much the latest. At least the latest I have. 15's probably out. Minimum distance 0. What puzzles me is this thing is never touched. All right, I'm going to put this back out. Let's see his. He did it on a text instead of a button, and there may be something to that. Text, foreground color, padding, background, corner radius, padding. We don't care. All right, we're going to use a normal text field. Oh, cute. Okay. Scale of look like this. Okay, so we'll change that to a text instead of a button. And we won't need this, but it's got a modifier. Maybe buttons don't like modifiers. I don't know. I think I took out the touchdown body. Yeah, so hopefully we see. Yeah, I would like to see this. Well, this should happen when you drag. Minimum 0, so it should be when you touch. Oh, did I run test cases? Yes, I did. All right, the goal of this, once we get this thing switched over, I'd like to get all our buttons in this press to activate mode. Okay, that's a reasonable thing. And then remove the keyboard stuff because we don't have a keyboard. And then, well, we'll see. I mean, that sounds like it'll take today and tomorrow or Sunday, next time I broadcast. The thing I want to do after that is at some point I had worked out transformations from polling-based systems to event-triggered systems. And I'd like to do that to this system if possible. And it may be a bad experiment, but we'll see what happens. Okay, notice it's black now because it's text instead of blue for the button. We can clearly take care of that at some point, but it doesn't make a big deal of difference. All right, we start moving. And that blank out, I would also like to address that. Okay, we'll stop, and I'll do a drag. Hey, there it goes. Too far? Nope. Okay. Now it's going. So it was the button versus text. Button must have too much stuff on it. Okay, and I'm stopping. Well, stopping like that is definitely what I wanted. But this one, the right hand keeps going until I hit the stop button. Just missed. Okay. Good enough. Got a few points. All right, there's all the stuff going on. Okay, interesting. I wouldn't have thought it mattered about text versus button, but apparently it does. All right, and so let's do the same thing. We won't need this button anymore because it's the cancel. Okay, and so this one, they're all going to look the same basically with just slightly different numbers. Okay, if the button is pressed, we want to do not 4, not 64. Notice the backward logic there, otherwise cancel. Okay, and we need the modifier. This modifier, and see where I got off here. Oh, I need a parenthesis. Then a spacer, then my random button. Same deal. I guess I'll just copy this whole thing. Text of star. Delete this. Oh, well, we need 4. Row 4, column not 2. And that can go. I'll reformat again. Okay, spacing's a little crazy there. We'll have to do something about that. That could probably just be a few spaces. A little padding. I was just missed. Okay. Sorry, we'll try again. Huh. Okay, a little trickery there. Yeah. Alrighty. Okay, I think that is working. Now we just want to do some tweaking down here. Let's see. So this, we don't need this to the end of the, whoops. We don't need this. All right, I'm going to try dot color. Color blue. Text. All right. Can we put a width on this or something? Minimum length. Well, I'm just going to do a text. Something like that. I just want a little space. I don't know. There's probably a better way. Go. That's acceptable. I just want a little distance between these controls. Maybe even 3 spaces would be enough. Yeah, it's got that little inchworm movement. It sort of shrinks and then disappears and then goes. I'm getting better. Alrighty. Yeah, that's pretty acceptable. Scale effect. Can I do 0.25? Just trying to shrink this and get the go up there a little higher up. Maybe I should put another spacer in. Okay, I ran it without, so I don't know, visual tweaking. My cycle is too slow. There is a preview mode, but I don't have it quite set up. All right, that didn't seem to change anything vertically, but let's see if this extra spacer in does something, and then I'll try removing the scale effect and see if that does something. I thought it did, but maybe not. Now I have to remember to hold them down when I want to move. Okay, so my priority is I'd like to get this stuff, get it move away from this keyboard matrix thing. So we'll do that, and then I think at that point I'd like to deal with that inchworm issue if that's easy to solve. I think it will be. I'm a little slow. Wrong direction. Okay. So yeah, let's fix the buttons to be more of a native kind of approach, or at least not go through this weird bit manipulation keyboard matrix thing. I think we can say there's four states. Either you're holding down the left, holding down the right, asking to jitter, or doing nothing. And I think that'll do it. So if we set it to produce one of those four states, and then the movement routines respect those states or reflect those states, we'll be in good shape. All right, we've been going a while now. Let's take a 2 or 3 minute break. We'll come back and get that turned into more of a Swift native approach, at least a little bit, and get the inchworm look out of there, make that a little nicer. I think at that point we might be ready to move on to a little deeper refactoring. So see you in 2 or 3. Hi, welcome back. All right, so we need to work on the interface between the two parts. Now let's see what we're left with here. We've got our content view. It knows the environment. For us, the core thing, well, the environment consists of the memory, which the video is all memory mapped, and it consists of the keyboard, and that's about it. Oh gosh, there's maybe one other piece, but yeah, that's what's affecting us at this point anyway. And we interact with it. Well, basically these buttons, we're telling the environment, here's some stuff going on. Now, where's our game? So here's game.run. So we don't have anything that communicates with the game right now, but what we'd like to do is make that happen. Okay, so let's we're gonna get something into existence. I would like to have a method on here. Well, basically, I want to define these states of controls, and then pass them in down to the game. Okay, so now should the logic try and set about those booleans, but I think if it's pressed, do this. If it's unpressed, clear it. I think that's pretty much standard between them. Okay, so let's see. So, well, I guess I want an enum. I know. I should keep a cheat sheet out here. Maybe I have one. Who knows? I keep stuff around and I never know where I've put it. I do know I printed out a lovely cheat sheet for Swift. But we'll use the world's cheat sheet. Okay. Yeah, I just need one liner. Then they could have summarized that for me. All right. Enum foo case blah. All right. So enum, I don't know, actions, action, case, none, left, right, jitter. All right. Sorry. I got worried about whether my mic was working. Okay. now I think what we want to say, I don't know, I'm not going to test it in. I've been very, mostly I've not been testing things in. I had the acceptance test and used that for the bulk of the stuff. So let's just put that, well, there's the drawing stuff, move paddle. Okay, so let's provide a method. It's got to be public because we're going to call it from the other thing. And I think what we want to do is say action, and then should activate is a Boolean, and then new action is an action. Fix it. Double typing there. Okay. And my idea with this is if should activate, then we're going to set action to new action, and then otherwise action equals done. Okay, and I think do we have we haven't defined an action yet. Okay, so let's put it down here. Well, let's put it next to this. var action is one of our actions. Okay, and it starts off with none. Did I say done down there? That should be none. Okay. Is that? Boy, I really hate that. Okay. Let's say act. Should activate with a new action. Okay. And that, I think, now what? Parameter uses an internal type. Okay. I probably should read these messages before I act on them, huh? Okay. Public enum. Okay, so now when you call act, it should activate. If it says yes, then we give it the new action, otherwise done. Okay, let's do this incrementally. How can we do this? How about well, how do I want to go about this? If the action is none, the question is, do I want to drop it all in at once or not? Let's try this. If the action is none, then let's assign keystroke. And I don't know what we have up there for key. Well, it's kind of anything else, right? So let's say key none is 0. Okay. All right. So I'm going to say then we want to say keystroke equals key none. X is left. Left. Case right. In case jitter. Keystroke is let. Okay. I'm going to get rid of it in a minute. I'm trying to get something I'm trying to do it in a way that I can turn it on and make it happen. Okay, so I think right now if I turn it on and I call game.act, that this move paddle will do the right thing. Okay, and then I'll inline those things once we got it working. So I believe this is the same as game.act with button is pressed, and this is our left. And this one is game.act with button is pressed and right. And correspondingly, I'll comment these. This is game.act button is pressed dot jitter. Good guess. And that. Okay, so my claim is this should work. And I guess I could have done them one at a time if I just default action do nothing and then I override first left, then right, then middle. Okay, go. You know, we'll take a look and see if there's any delays in the drawing here. I don't think so. I made some sort of guess about, okay, we're moving left. Let's try jitter. Yep. Sorry, that was moving right. This is left. Get over there. Nope. Okay. Good enough. All right, so that's working. We can clean up this. And now we can, since there's only one reference to it, we can just use $0. And I don't know, I think given that it's on it's likely to be a one-liner. Boy, their guess on how far I want to jump to the right is just bizarre. You'd think for a programmer's editor, they would have it right. Okay, not going to quite fit. Okay, so we'll do this. I guess we'll put this back out. Oops, too much. How about we just delete the commented stuff? Now, I wonder if I can move this out to the H stack. Okay, so I think this gets about as good as this is going to be. You either move left, you move right, or you use jitter, and whatever the argument is that tells you what to do comes in. Okay, the Boolean's a little raw. Okay, I'm going to take this out and see if it has any impact. Try and do a little screen manipulation, a couple things at once, if they don't seem like they'll interact. Button should be blue, and the whole thing should be a little tighter. Or it shouldn't matter. I don't think it matters. Is that smaller? I do believe it is. Okay, what did we do on this one? Oh, that was the screen view. Okay, then I definitely want that. These are blue. That's a good thing. We are moving. Okay. So let's go back to blocked. And I really should have pushed before now. Okay, so what I want to do is kind of cut out the middleman. I don't need to look at the keyboard stuff, period. Okay, if the keystroke, if the movement is left, then really what I want to do is the key X case, which is this. All right, and I don't need that anymore. And keystroke none is just default and it does nothing. Okay, keystroke C is moved to the right. Give a little air here. This will be a break. And finally, keyboard comma is this. Okay, and I don't think I need switch stuff at all. Okay, this should be fine. We'll flip through a test at least. Get the naive. I don't think the test can really detect this change. They might. Oh, they might fail. Let's see. I don't know. We are probably setting keyboard address stuff in our test, right? So let's see what the test looks like. Yeah, we need to we'll need to change that. Yep, test failed. Good. Well, I feel good in a way. All right. Okay. Runs them in whatever order it wants. Yep, first test passed because it doesn't do any movement. But now the way to make our game move is we want to say game.act. And it's true that we want to do this, and we want to do .write. And this can come out. Okay, so start the environment, start the game, set the game to run hard to the right, and run. See what happens. Okay, and let's do this again. So here's that hash I was telling you about, right? So we kick off the game, just hit run, don't move. What happens at the end? Well, it bounces one, knocks one thing off the screen and does this. And this one basically does the same thing, except that it moves the paddle hard to the right. It says move to the right every chance you get. Every time you pull, it goes to the right. So I think what we've done, let's give the real thing a run. I'm trying to think in terms of actions. I think we had actions that like press the left button and then press and then release the left button, press the right button, release, and press the jitter button. And those we've sort of turned them into semantic events that make sense to our game. Move left, move right, done and none and jitter. Without much translation going on. The work is in our stuff. Now, I didn't test it because I'm being lazy and I'm not sure how much value in the test. It's like, these interaction ones, they're, harder to set it up as an interaction test. I can test that if you set a flag, you set the value, but I'm not really too concerned there. Okay, are we running yet? Yes. Back to full size. Now, it would be interesting, like, I don't know how my acceptance test, could I make one? Like, I'm saying go hard right. It's time-based, so it's a little tricky. Maybe I could do something that, I don't know, could I say go hard right for so many ticks? Like how many consultations you do of the action? Or maybe some sort of stream of events? So yeah, maybe there's a queue, and you feed events in when they happen. I don't know, with that polling, it's a little tricky. See if I can cheat with the jitter. Yeah. Okay. It's not cheating. It's part of the thing. Okay. Let's get this cleaned up and at least check it in. Okay. So we don't need the environment stuff, the poke keyboard stuff. We're doing things, whether they're clear, I'm not sure. But one thing I know goes on. Move paddle. Who calls move paddle? It's probably up here. Words. Okay, that has some delays. I guess let's answer that question. Is there a delay in the drawing's initial screen? I don't think there is. Nope, they just do their pokes. We can see if poke has any built-in delay. screen. No. So it's oddly slow. Screen address. Yeah, I don't think that's an issue. Okay, back to blocked. Okay, we've got all those comments out. Now let's see who's using these things. Is anybody using it? Callers. Nope. Okay. One small bonus. Okay. Let's see what else. Paddle. These memory references. Yikes. We probably could do something about them. I don't know. All right, so yeah, clear paddle. Where's that called? Oh, clear paddle -1. So if you're moving left, we poke a space in the paddle and the paddle next. All right, let's check this in and then think about our inchworm. All right, so we let's see. Did we? We made the buttons act on touch up or touch down, then removed all key related references in the code. We'll then use that to remove key related references. All right, so you clear the paddle and the space, and then you, with the two spaces, but the direction, let's see, I think this is always ±1. Let's find all colors. Oh, I have to do it here. Color. That was weird. Since there are colors. Okay, let's find all. Right, those three. Yes, so this is really ±1. Okay, if it's -1, we start with a character in paddle and paddle +1. We erase how can I get a decision? See, clear paddle, I don't even think this belongs in here, right? I mean, this is really move paddle. It would be nice if it were clear paddle, move paddle, draw paddle. Let's make that happen. Because if you do jitter, you don't even move the paddle. So you poke two spaces, direction is unchanged. Well, it's not called. So you just set horizontal and you draw the paddle. You haven't changed it, so it's drawn exactly where it was. No harm, but not very useful either. Okay, so I'm going to pull out this. I'm going to make a method move paddle. And then at some point, I'm going to inline everything and make it all better. Okay, Now move paddle is called everywhere at the end of clear paddle. So I could inline and re-extract, but I'm just going to pull it here because it was called at the end of move clear paddle. We know there's only 3 references, one of which is the definition. Okay, so now I got clear paddle -1, move paddle -1, and move paddle +1. Okay, because direction's passed in. Okay, now can I move too far left? How do I know when it's safe? Did I just name the same thing? I did. Let's inline this. Direction is -1. Okay, and inline it here. Direction is +1. And this move paddle is no longer called. Okay. Notice now, nobody uses the direction in here, so I'm going to delete this off here. And here. And here. Okay. Now, move paddle has already been decided. No. Well, somebody's got to decide. Wait a minute. Oh, there it is. If paddle's less than screen paddle max and min. Okay. So if the paddle's greater than screen paddle min, then we're, well, the furthest left we can be is right screen paddle min +1. Okay. So we know it's safe to move 1 square to the left. All right, let's pull in this. Okay, so I don't have an inline either, so we're doing it manually. Clear paddle. Okay. And then draw paddle. Well, I made the argument that if you didn't clear it, you got no reason to draw it. So none doesn't need it, and jitter doesn't need it. Okay, so let's maybe move none down. And actually, I kind of think of it as being last anyway too, but we'll leave that there. Okay, so where are we at? Switch must be exhaustive. Oh. Cut from here, paste it here. All right. So what we're doing is we're drawing a space at paddle. Oh, let's get our last one in. Draw paddle. Well, I've screwed things up, haven't I? Draw paddle happens in 2 cases. This one and this one. We don't need to draw it in the other 2 because we never erased it. All right, now I'm going to move this down. Okay, this is now happening in all the places it needs to. Okay, so draw paddle is this. We're going to inline this and inline this. Okay, now I don't think anybody's using these, so let's let that be. All right. Now we're going to trace through the action. Okay, let's say paddle is 10 because we don't care what the number actually is. We poke a space at 10 and 11. Then we move paddle to 9. And we draw at the new paddle character a space, a bar and another bar. All right, so I put it to you that this one at 10, okay, so we clear 10 and 11. We set paddle to 9. we write 9 and 10. Okay, so that's the flashing we're getting. We clear 10 and 11, we draw 9 and 10. Okay, so there's no point clearing 10 because we're going to draw it again in a second down here. All right, so if we don't clear it, we don't need to draw it. And let me just make this a -1. Okay, poke paddle +1 space. So yeah, we couldn't even, I don't know, maybe this is better moved around. But anyway, we're saying if you're at 10, clear 11, move 1 to the left, so you're at 9, and then draw the one at 9, so the one at 10 is still there. All right, I'm going to do the same argument moving right, okay, only I think it's the other end. So moving right, we draw, let's say we're at 10. We clear 10 and 11. Now we move our paddle to 11, and we draw 11 and 12. Okay, so we do need to clear 10, but we don't need to clear 11. And this is now 11, so we don't need to clear it. All right. Let's see if I'm right. And I think we can do even better. But my goal is we don't have that flashing on the bar we're drawing. Go. I really have to find the delays, but anyway. I can't believe it's this slow to draw. We still get a little shrinkage. I don't think we're going to be able to avoid some. So I would say it's doing the inchworm thing, but notice the middle one's not flashing, so you don't ever get a white space kind of thing. The thing is, well, and maybe this is why it's so darn slow. The screen redraws every time, every tick. Now, supposedly, it's going to notice like most of this stuff is unchanged and only these cells have changed. But I don't know. Got a little race here. Yeah. So part of the thing is, let's see. Not too slow. Okay. Yeah. What can we do about this? I don't think we can do anything exactly. Let's see. Do we? The problem is every poke changes the screen and we monitor the screen for changes. So there's really, whatever, 600 cells or something like that on this thing. Well, 24 by 24, 496, whatever it is. There's that many cells on there. Every one of those gets monitored and we redraw every time one changes. So if I have no way to remove one side and poke the other side at the same time, which is too bad. But I can do better. I could stretch it and move it. Okay, so let me try one thing first. I'd like to move this up. Let's see, is that nope. We'll cut and paste. All right, now paddle goes to paddle -1. Well, paddle minus paddle +1 is paddle +2. All right, because I'm dealing with a one smaller paddle, so I got to add 2. All right, and that means I'm shrinking. Let's see if I can do it the other way. If I draw the new one and then I erase the old one, I'm going to have an inchworm that's, instead of 2 going to 1 going to 2, I'm going to have 2 goes to 3 goes to 2 on the left. Let's see how we like it first. Whoops. Okay. We'll take a look and see what we think. And while that's warming up, let's see if we can find environment. Where do we call delay? Okay. It's not quite there. That's the function. We don't. Okay. All right, so it should be a 1, shrink 1 to 2, 2 to 1 to 2, and then going to the right, and then 2 to 3 to 2 going to the left. Also, there's something wrong with our startup because we don't show it initially. Okay, that shrinks to 1. Yep. Now, is that better? I don't know. I think it is. All right, let's repeat the action. And this is, I don't know, this is almost like program proof kind of stuff. All right, I've got paddle. If I increase it by 1 and I reference the poke, that should be paddle -1. Now I only moved it above 1 line, so only that line is affected. Okay, so paddle was 10 going in, we've modified 9. Instead, we're making paddle 11. And we modify 10. Okay. Before we came in, let's see, let me undo it. Yeah, before we came in, we were at paddle. Now we're coming in with paddle 1 bigger. We got to make it 1 smaller to make things work out. Okay. And now we're poking the space. We can poke the space after we poke the extra character, and we get a little better look, I think. I think the flash of white while it shrinks is more significant than the flash of white after it grows, I guess. Is that a thing? All right, now what's weird on this side, I'm bouncing while this thing runs. Like, who calls delay? Let's do a global search. Delay. Okay. And we got to deal with that initial value. Somebody drew the initial screen, must have the paddle. All right, go. Initial screen top size blocks. I guess somewhere we need to place the paddle before we get started, I should say. Oh, okay, because I took it out. That's what it is. I took it out of the none case so it doesn't draw when none is there. So we haven't set our initial conditions properly. All right, let's do that. Okay, so starting point, we had to draw both characters. All right. I don't know if this optimization is a good one or not. What would really be more helpful was if I had some sort of transaction going to the memory. I don't think I can, though. I think the way it's set up, the environment is, it's monitoring the memory directly. Yeah, the screen is a published field, a published array. So you modify this array, somebody gets notified, and all that stuff. All right, now the other one was the delay factor. Let's see, in here, delay should be in the main loop. Yeah. Okay. And yeah, we went around on this. So each time through, there's a delay, but there's nothing on the initial screen. That's just mechanism. It's not a good sign to me. I mean, 500 objects or whatever is a lot of objects, but yeah, some seems kind of slow. All right, let's make sure the initial paddle is there. And okay. I'm wondering what we could do to make it more transactional. You know, I'd like to be able to say, move the two paddle squares. I don't know if I would need a whole mechanism just for that, but that seems like a lot of it. Now maybe there could be a way to hook it up before you got going. I don't know. All right, so the initial paddle is there. I haven't hit a button yet, and we move. You can catch a flash of white once in a while. And let's play with this. Okay. All right. Well, we're kind of due for a break. Let's make another 2-minute break and come back and see what we can do from there. All right. See you in a bit. All right. Welcome back. So I think we're definitely to the point of committing this. So we made paddle drawing show 2, then 3, then 2, rather than, let's see, it was 2, then 0, then 1, then 2. Okay. Yeah, so that's probably part of the issue there. Because, yeah, we're definitely showing, we were clearing both, so we 2, then, well, it's really 2, it was really 2, then 1, then 2, then 0. So we started with 2, we erased 1, then we had 1, we erased that, then we were down to 0, then we drew the first one and drew the second one. Now we're showing the 2, we draw the new one and then shrink the old one. Okay, so it was probably a little faster. I don't know. I'm not sure I could measure the partial seconds on that, but I think you know, this is 5 steps. This is 3, so there's definitely some overhead on drawing. Okay, let's go back here. Let's see where we're at on things. Okay, so I'm going to start at the top and just do a little code review of everything. So we're using SwiftUI, which is a relatively new text-based drawing specification language, I guess you would say. And it's, I don't know, it's probably 3-4 years old at this point, but newish. I'm trying to just use that because I'm not working on some team with a real app, and I can live with the fact that this thing's a little new and balky. I have another app I'm helping somebody with. It's UI Kit, and they can use all the features, and it helps them in that case. For the toy stuff I'm doing, I'll live with SwiftUI. Okay, and the way you work is you're an app. You start up a scene. You got a window group, and you put your content view in there. In our case, we've got the environment and the game blocked, and we are basically passing those into the content view. And you don't have to call it content view. That's just sort of the default name. Okay. Oh, character set was the other issue the environment owns. Okay. And we're still not quite smooth on how we handle all that. But anyway, you can see we observed object says we're going to hold the environment and get notifications when it changes. And then game is also observed, and we'll get notification when that changes. Now, I don't know if our game... Let's see. Publish. Okay, I have a feeling we've pulled out anything that would make that matter. Let's give it a try. So this is no longer observable. And this is no longer observed. All right, let's see if everything looks good. Okay, so observed object says this thing's got published fields, and we definitely, well, where'd it go? We definitely saw them because that screen was a published field. The keyboard's a published field. Okay. Now, to my eye, the thing that's not changing looks very steady, so I'm happy with that. So I think that's good, and there's no refresh issues or anything like that. Okay, I did a jitter. Yeah, we need, the old computer didn't have sound effects, or you could, well, back in those days, right, you were probably enough of an electrician or electrical engineer that you could wire up a speaker to it and write some little routine to go tick, 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 tick as quick as the machine can go and get some sort of beepy boopy sound. But nothing compared to even the later computers, like Commodore 64 had a little 3-voice synthesizer chip in it. That's only a few years later, a couple years later. Okay, I think we're good. So we got rid of one observable, so that probably sped it up a hair. Okay, then you can see the drawing stuff. So I don't know if you've ever done HTML manually to draw a screen with rows and columns. It's kind of like that. I've got a VStack of everything. Okay, that's all that. And then I use spacers or contents of some sort. So screen view is a separate, it's a separate object, basically, a separate view. And I scaled it. It was a little tiny before. You put a spacer in, and you're basically delegating to the drawing system the exact layout. And it's kind of the benefit in the curse of using this Swift UI approach. So if I change screens or something like that, my hope is stuff gets squeezed in. And, I haven't even done that here. Let's see, I think it's this. Yeah. Okay, so it's a little too tight for it, isn't it? The button is laid on top. This bar down on the bottom, that's part of... you don't have a choice on that. Okay, I'm losing, like the very top must be right at the very top. Now these buttons layouts, I don't think they're not going to be, the ball won't hit them or anything like that. Okay, so we've let the system just kind of make a judgment about how to draw things differently given the space constraints I gave it and all that, like, what can we do different? And, it chose to kind of do some overlaying instead of, I don't know. Probably what I'll have to do is specify like, oh, put the controls on the side if the layout, if it doesn't have room or something. Okay. So, I missed something there. Let's go out of the way. Did it bounce on the G? No, let's see. We've had it. Fail. Interesting. Okay. Well, maybe... Yeah, I'm not sure what's going on there. Okay. Well, I don't see how that would happen. Oh, I do. I think... Okay, let's run it again. Yeah, there's leftover junk on the screen layout. Yeah, so this thing doesn't really let you change layouts very well. Yeah, interesting. Okay. So, yeah, that's not supported at this time. We'll have to look into it. Okay, at any rate, we have the main screen, and then we have this horizontal stack of the buttons, left, right, jitter. And then on the bottom, a go button that actually triggers, it prints this in the environment, and then it runs the game. Okay, notice it's async. That's so that we can update our memory, and when it sends a notification back to the screen drawing stuff, all the screen drawing has to happen in the main thread. So we've got to keep the game itself running in a separate thread. All right. Now this, there's so much stuff. I think we started putting some stuff in the OSI environment for this. Let's see. OSI. Right. I defined a few shapes. They're static. We could probably use them. All right. So we'll just do a little more refactoring as we're going here. Import char set OSI. Okay. So the 128 is row 8. Okay, so let's just say it's char set OSI, char set row 8. Okay, so the basically 8, it's an 8x8 character, so row 8 is just the bottom row filled in. There's 8 rows, 8 columns. Okay, the left wall character 143 is column 8. Okay. And the right 136, I'm pretty sure is column 1. Column 1. Square black is 161. Okay. The ball is 226. I don't know if we have a character for this. No, we don't. All right, I'm going to break my habit here, comment, And the paddle 135. Let's see, there it is, row 1. Okay, so it pushes the paddle drawing to the top. All right, row 1. All right, it kind of tells me we probably should name the space here, although I don't think we're doing the best job possible on the character set yet. I think well, we don't even have them all. Right? I mean, I've got 2 of the rows, 2 of the columns, a black square, a ball, and a plane. I don't think this is terrible in the sense that this definition, top character, left wall, right wall, those are all things discussed in our game. And I think that's all right. I mean, that's kind of what we want. Okay. These are, well, this is all about screen memory. Okay. So, is it 53381? Let's find environment. Screen. 53381. Okay. Yeah, I'm not sure that's as helpful. Oh, that's coming from here. Wait a minute. Have I got 2 screen? Oh no, screen view moved in. Okay. Yeah. So screen view is a SwiftUI object, or well, it's a view. And basically it's the thing that draws the memory. So it's used to be part of the app, and I pulled it over to the support because anybody wants to display the memory. It's a reasonable thing to do. And this is all based on that. But somewhere the environment defines, like 53381. Yeah, that's screen start. Environment.screen start. Now I don't know if we can, well, environment is owned in the other project. Or SwiftUI. Screen view, sorry. What do we have in our code is, so I think these constants, 53541, I don't know, it's really, let me move this down. It's a function of those randomish numbers that define the memory stuff. All right, so here's init. I want to define this. Let's see. What's 53541? Sorry, let's go to the other one. Wake up, 53541. Minus 53381. Okay. $160. Okay. If I divide that by 32 is 5. So 53541, let's see, let's do it the other way. 53381 plus 5 times 32 is 53541. Okay. So this is really that, and I'm going to make the initializer defined it. Okay. So this is screen block start. And it's really 53541 plus 32 times 5. Well, 5 times 32 probably reads better. Okay. Now the 32, I didn't pick that at random. That's, our screens are 24 wide, but they have 4 guard bytes on each side. And it's to do with the memory cards and which screen size you have and all this stuff. But in any case, the screen memory, to draw one row further down, you don't go by 24s, you go by 32s. So this is saying take the top left 53381 plus 5 times 32. Take the top left corner and go down 5 rows, and that's where you're going to start drawing balls. And if you look at the way the balls go, they, let's see, draw blocks. Sorry, blocks. We're starting at screen block start and plus starting at 1. So the top left corner is actually an empty square, and then beneath it are a bunch of vertical lines that represent the left wall. And our starting point is the row, it's a left wall, but we're starting at 1 here, so it doesn't draw on that. All right. I don't know if that helps any, but this number has a name. It's environment.screen start. Okay, let's go to environment. Screen start is 53381. And this 5, that comes from the game. That's a decision, how many rows down do we want to go. But the 32 is screen line distance. Okay, so this is environment.screen line distance. Okay, and that's where we're starting to draw our blocks. So this, I'm making these be a little bit more semantic, I guess. All right, the ball start, I don't know where that is. 54090. 54090 minus 53381 is 709. If we divide that by 32, we get 22 and change. Okay, so let's go the other way. 53381 plus 22 times 32 is 54085. Okay, but we wanted 54091. All right, so if we add 090, so if we add 5, okay, so let me break it down again that way. This is screen ball start. We're going to initialize it here. Screen ball start. Equals environment.screen start plus 22 times screen line distance env dot screen line distance plus 5. Okay, where's our ball start? I'm going to make this an int. All right, maybe that's enough to try things out. Okay, let's see. Oh, 0. Yeah. Did I say run? Oh, build failed. Something's... No such module. Oh. I hate trying to wake this thing up and convince it like, yes, the module that's sitting right there in your library is really there. But sometimes that's what it takes. And you can see why I want to use these constants correctly, because like I don't want to multiply by 32 being space character. You know, this number is a meaningful number. Oh, I don't think we reference keyboard address anymore. Find selected text. Yep. Okay. We'll be able to delete that. Well, meanwhile, we can work on this. 54118 minus 53381 divided by 32 is 23. Okay. That is 54117, so we got to add 1 to that. Build failed again. Well, did I mess up charset OSI? Are you public? Yes. Am I supposed to have a... I wonder if I'm supposed to give these a package or something like that. But I don't think it's looking any different than environment. Here's environment, public class environment. Here's this, public class OSI. This stuff we're using is public. Make sure this error is where... Oh, man. Am I spelling it right? Char set capital OSI. Char set capital OSI. Char set capital OSI. Okay. Well... Why that would start failing now, I can't tell you. But we're basically at the end of the day. Let's see if I can record this. 54118 is an int. Screen paddle min. Screen paddle min equals screen start plus 23 times screen line distance plus 1. Clean finished. He's not complaining. All right. 54138. Well, that's kind of this plus 20, isn't it? Is screen paddle min plus 20. And it's an int. Okay. Well, I'll give it a run and we'll see. So next time is Sunday. Let's see, that's the 22nd of August. And we'll pick up from here a little bit of walkthrough on the code and see if we can... I think I'd like to start trying this refactoring experiment to make it event-based instead of polling-based. I think we have a little trickiness there from some timing stuff, but let's see what we can do. And I'll do some rebooting and see if I can get this thing to wake up and realize it's got this thing sitting right there. But thanks for joining me today, and I hope to catch you in the future. Have a good night and good weekend. Bye-bye.